So hi guys, I hope you all are doing well. In today's video, we'll be starting with our chapter 10th of class 10th mathematics, that is circles. In the last chapter, we saw the concept of trigonometry and the applications of trigonometry. So I hope you have practiced the chapter well. And so let's begin with a new chapter, that is circles. So we have studied in class 9 that what is a circle? A circle is a collection of all points in a plane which are at a constant distance from a fixed point, that is the center. So if I were to draw it on a, let's say if this is my center point, circle is a collection of points at a fixed distance from the center of the from a particular point, that is the center. So all of these distances are equal. Therefore, I say that it is the radius, right? So that is a circle. Circle is a collection of all points in a plane which are at constant distance from a fixed point. Okay. Now, we have studied various terms related to circle like chord, segment, sector, etc. Right. So in this chapter, we are going to see some special conditions where we'll be learning new terminologies regarding the circle. Okay. Let us take an example that let us consider a circle and a line PQ. In the first case, the line PQ is lying outside of the circle. Therefore, that is the non-intersecting line because it does not intersect with the circle. There is a distance between the circle, right? So it does not intersect with the circle. In the second condition, we have PQ line segment inside the circle, and that is intersecting the circle at 2 points, that is point A and point B. So this particular condition, so therefore the line PQ is called as the second of is called the second of the circle. Now, in the third case, the line PQ is intersecting the circle such that it intersects the circle exactly at one point only. Now, if you will say that no, we can see various point over here, but if you just zoom in at a very minute level, so you'll come to know that this is the only single point that the line segment PQ intersects at the circle. Okay, so therefore this particular condition is called as tangent. So therefore the line PQ is tangent to the circle. So in this chapter we are going to learn about tangent and its properties with respect to the circle. So therefore in this particular case the second of the circle becomes a tangent to the circle. Okay, so therefore we can say that a tangent to a circle is a line that intersects the circle at only one single point. Remember that it intersects at only one single point, no more points than one single point. I hope that is clear. So that is called as a tangent to the circle. Now you may say that कि अच्छा उधर तो ये एक मानो मेरा सर्कल है, ठीक है? So tangent could be anywhere. I- If I take if I take this point, so I can draw a tangent like this. Let's say this is point A. Okay, this is a line segment. I can draw a tangent like this, let's say like this. So this is a point, let's say B. So this is a line segment. Okay, but it intersects only at one single point on the circle. So that is why it is called as tangent. You can see over here that also therefore we can say that there is only one tangent at a point of the circle. Okay, we can get infinite number of tangents on the circle because we have infinite number of points, right? Like we don't have infinite number of points. We have a particular collection of points. Okay, but for a single point o- there exists only one tangent, not more than one. Okay, I hope that is clear. So therefore, the tangent to a circle is a special case of the second when the two end points of its corresponding chord coincide. Okay, I hope that is understood. Moving further, we have theorem 10.1 that states the tangent at any point of a circle is perpendicular to the radius through the point of contact. That suggests if I have a circle, okay, this is my center. Now, if I draw a tangent to the circle. Let's say this is a tangent to the circle. Let us say this is at point A. My center is O. This is line segment PQ. Now theorem 10.1 states that if I join the center and the point of contact of the tangent, so that is equal to the radius only. So the line segment, so basically PQ is the tangent, right? So PQ is tangent. So the angle between the radius OA and the line segment PQ, that is the tangent, is 90 degrees. So therefore, for at the point, it is only true at the point of contact and not anywhere else. So therefore, the line OA is perpendicular to PQ, or else we can say that the radius is perpendicular to the tangent at the therefore we can say that the tangent is perpendicular to the radius through the point of contact. We can see that now if I pass a tangent through this point, let's say this point, so this is also 90 degree. If I pass it through this point, so this is also 90 degree. Okay, I hope that is clear. Cool. So yeah, so therefore we have exercise 10.1, that is very simple and you can solve it on your own. Next up we have the number of tangents from a point on a circle. Therefore, there are three cases that we can summarize over here. That case one is there is no tangent to a circle passing. Uh, my bad. There is no tangent to a circle passing through a point lying inside the circle. If I have a point lying inside the circle, let us say this point. So there is no such tangent that passes through this point because it becomes a secant, not a tangent. Okay. So therefore, if a point lies inside the circle, there is no tangent that exists and that passes through the point that lies inside the circle. Okay. Case two is there is one and only one tangent to a circle passing through point lying on the circle. If I have a point lying on the circle, let us say this point Q. So there exists only one tangent that passes through this point. Okay. It could be anywhere. It can be any point on the circle, but there exists only one tangent. So for point Q, there exists only one tangent. Let's say for point A, there exists only one tangent that passes through the point that is lying on the circle. On the circle means that lies on the circumference of the circle. Next up, we have case 3, that is, there are exactly two tangents to a circle through a point lying outside the circle. If a point lies outside the circle, there are exactly two tangents that can be drawn from the point to the circle, or tangents that can pass through the point that lies outside the circle. So therefore, if I take this point, point P, there are only two such tangents that pass through the point. So if I take this point also, let's say this point. So there are only two such tangents that pass through this point. That let's say it is a point Q. So therefore, the length of the segment of the tangent from the external point P and the point of contact with the circle is called the tangent length of the tangent from the point P to the circle. So therefore, we can say that this much from P to T2 or from P to T2, this is called the length of the tangent. ठीक है so basically the length of segment of the tangent from the external point of contact with the circle is called the length of tangent from the point P to the circle. I hope that is clear. Therefore, we get our theorem 10.2 that states the lengths of the tangent drawn from an external point to a circle are equal. So therefore, if I draw two tangents, I can draw only two tangents from a point that lies outside the circle. Okay, so the lengths of those two tangents are equal when I draw them from a point that lies outside the circle. Okay, so therefore from here I can say that PQ is equal to PR. So therefore the length of the tangents is equal over here. One more thing you can notice that the line segment PQ and OQ are perpendicular to each other, and the line segment PR and OR are also perpendicular to each other. If I say that OQ and OR are the radius of the circle. radii of the circle. ठीक है? I hope that is clear. You can just read out the proof from the textbook and understand it on your own. So yeah, so these are some of the theorems that we need to study for the chapter circles, and we are done with this chapter. We only had two theorems in this chapter. Let us just quickly summarize what we have learned. That we have studied the following points, that what the meaning of tangent. So basically, tangent is a line segment to the circle that passes through only one single point lying on the circle. Let's say point A, P, and Q. Okay. What does the theorem 10.1 states that if I have a circle and I have drawn a tangent to the circle, so the radius through the point of contact of the tangent and the tangent are perpendicular to each other, are at 90 degree to each other. This was theorem 10.1. Right. And the theorem 10.2 states that if I have drawn two tangents from an external point to the circle, so therefore the lengths of the tangents are equal. Let's say PA and PBO. So PA is equal to PB. And also you need to understand that OA is perpendicular to AP, and OB is also perpendicular to BP. ठीक है? I hope that is clear. We have learned these three major concepts from the chapter circles, and we are done with this chapter. I hope you have understood all the concepts and theory from the chapter circles. You can just read out the chapter once from the textbook, and you are good to go with the chapter. Read the solved examples and solve the practice exercise that is given, exercises that are given in the textbook and that are given in the chapter. ठीक है? I hope you have understood all the concepts. If you have any doubts, please put it in the comment section. I would definitely love to clarify them. So thank you so much for watching this video. We'll meet in another video. In that chapter, we'll be studying about the areas related to circles. Thank you so much for watching this video. Have a good day. Take care. Bye bye.
वीडियोस बनाने हैं, फिल्मोरा है ना।